So this is Zero Buddy. I'm the CEO here at Immersive Experiences, and today we've been running a variety of shows for our families at the Lambeth Country Show, and of course the Sutton Science Festival as well. We've joined today by Professor Patricia Reiff from Texas, USA. So she's about 6 hours behind us, and she's very generously agreed to do a presentation and introduce some of the topics that she'll be covering. And she's a brilliant role model for women in STEAM. So if you've got any questions, do direct them to her, either unmute your mic or type them in the chat window. Otherwise, hope you all enjoy the show, and we'll speak to you later on. Great, over to you, Pat.
Great. Well, it's nice to have you all here with me, and thanks, Z, for the invitation. It's early in the morning my time, but not too bad. But I did stay up late watching the comet last night, so it's a little early for me. So Z asked me to talk to you a little bit about women in STEAM. So I have this little PowerPoint. I know people hate PowerPoints, but I'm going to kind of go through some of the interesting things about women in space. And so if you've got questions, please use the chat window. I may or may not be able to see the chat window when I've got the PowerPoint up, but I can, when we stop, I'll be happy to look and we can go through questions at that time. Since there's not very many of us, if you want to just unmute your mic and ask an audible question while I'm talking, I'm happy to do that too. All right, so I'm going to share the screen. And I'm going to start this PowerPoint. It's amazing how these things disappear on you when you're... okay, so I'm going to talk a little bit about not just women in space, but women in not just women in STEAM, but women in space, because, you know, that's where I am. And that's one of the really exciting things that women have made a impact in the last few years. So to go with women in space, you really have to look at women astronomers, because women have been astronomers for many years. Here is Carolyn Herschel, who was the one who discovered several comets. Maria Mitchell observed sunspots and also discovered a comet. Annie Junt Cannon and worked with Pickering's lab, did the stellar classification, Oh Be a Fine Girl, Kiss Me. And her friend Henrietta Leavitt showed that the period of pulsars, of Cepheid variables was related to their brightness, and that way they could get a distance scale for the universe. And so these women were really critical. They were usually used to make tedious calculations. They were called computers because they did the computations, you know, back before we had computers. There are other women very famous, and since then, of course, one of the most was Jocelyn Bell Burnell, who just as her graduate study, PhD research, discovered pulsars. The fact that certain radio stars beep in the radio spectrum, and but one of the really sad things about that was that her advisor got the Nobel Prize, not her. Just to show you what this sounds like, here's the Vela pulsar. So those knockety knocks are once per spin of that supernova remnant. So it's going around really, really fast. And we can look at the Crab Nebula, which is even younger and spins even faster. So each buzz there is a spin of the spacecraft. Katherine Johnson, another one everybody knows, just passed away just this year, She was crucial in making the flight calculations for both Mercury and Apollo. Women were famous aviators. John LaBrosse, the first dirigible pilot, Harriet Quimby, and of course everyone knows Amelia Earhart, who was the first to fly solo across the Atlantic and was trying to do a solo across the Pacific when she went down somewhere. The first woman in space was Valentina Tereshkova, and she was a Russian and was very, in fact, still alive, is very forthcoming about people in space. And she was chosen because she was a balloonist and a parachutist. And so she knew, what it was like to be in space and the risk you had to take. The second woman in space was also Russian, Svetlana Savitskaya. And this is her picture over here. The first American woman astronaut was Sally Ride, who flew in 1983. I knew Sally when she was an astronaut, and she came up to Rice fairly often to come to our astronomy seminars. She was dating one of our postdocs there. Of course, since then she married a woman, Catherine Sullivan, Eileen Collins, and Peggy Whitson, all major outposts in space. Catherine Sullivan, just this last week, was the first woman in the Marianas Trench. So she was the first woman EVA and the first woman at the deepest part of the ocean. Now, there have been women, unfortunately, who have died in space, and the Challenger in 1986 had two women aboard, Judith Resnick and Krista McAuliffe. This is Krista and there's Judy. Now, technically, Krista, because they didn't make it up to 100 kilometers, she wasn't really considered in space, but it was certainly on her way to space. Then the second major crash was the Columbia incident in 2003, and that also had two women on it, Kalpana Chawla from India and Laurel Clark. Now, Rice University, where I teach, has had a number of faculty or students that have been associated with, that have been astronauts. Not all of them have flown. Kurt Michael was one of the first scientist astronauts, but when they canceled Apollo, he retired from the astronaut corps. John Bull was an astronaut, but passed away before he could fly. But the rest of these have flown in space one or many times. As I mentioned, Catherine Sullivan was a adjunct professor. Jeff Hausman was an adjunct professor. Frank Diaz was a PhD student of ours. Tamara was PhD. Jim Newman, PhD. Janice was a graduate student. Peter Wizoff was an adjunct. Takai was a PhD. Peggy was a PhD. Mike Mazzamino was director of the Rice Space Institute. John Olivas was a PhD, and Shannon Walker was a PhD. So we've been very lucky to have many Rice people in space, and Shannon is still in the Corps. Everybody else has retired. Well, space is not just for white people, it's also many astronauts that were Black or Indian or Native American or Hispanic have also been involved in space. And of course, these four are the hidden figures of the movie, which was an amazing story. But there are a lot of women that are space scientists now. This is Fran Bagenal, one of my good friends, who's involved in Juno and New Horizons and many of the outer solar system missions. And these are all the women that are part of New Horizons that flew past Pluto and then past Ultima Thule, and is still on its way out of the solar system. Um, Here are some of the women that are associated with the various Mars robotics missions. So it's women are very active in planetary science and in astronomy and in space plasma physics, which is my field. So this is the Parker Solar Probe that was just launched a couple of years ago, and there is Gene Parker that the mission was named after, because he was one of the ones who really first understood what made sunspots and the solar wind. And that next to him was Nikki Fox, who is the director of the heliophysics division at NASA. So the current mission that I'm on is the magnetospheric multi-scale mission, and we also have a fair number of women, including the project scientist was a woman, although she's now moved up to be the heliospheric director. So these are some of the team members from the mission I'm on right now. Now, what's next? Well, we are heading to more of the commercial use of space, and so we have new commercial crews designated. And these will be flying either in the SpaceX Dragon or in the Boeing Starliner. And of course, the first Dragon mission flew in fact, still connected to ISS right now with Hurley and, but Nicole Mann will be one of the later ones on the commercial astronaut Boeing crew. And these are the ones that are up right now on the first commercial test, Bob Behnken and Doug Hurley. And we had a live watch party for that, which was really, really awesome. But coming up in the next SpaceX flight will be my good friend Shannon Walker, and she's even taking up my mascot Trigger is going to be flying with her to the space station. So we're very, very excited about that. So she spent nearly a year in space, and this is her in the cupola, which of course is the most beautiful, most fun place to be out in space, in the space station. And also Suni Williams is also scheduled for the first Boeing operational mission, and she is an amazing lady too. So the idea was that low Earth orbit would become more commercial based flights, so that NASA could put its resources into the moon and Mars and beyond. It's been almost 50 years since humans have been outside of Earth orbit, and that's just really, really too long. So George Bush had his first idea to do what was called the Constellation program, which is first to finish the ISS, then go to the moon, and then move on to Mars. And that was a plan back in 2006, and like many plans, it was a very ambitious, but not hadn't made it yet. So the idea is that they would create a sustained human presence on the moon. Well, with lunar landings, crew exploration vehicle, which was called the Orion, and a heavy lift launch vehicle. And this was the schedule that was originally planned. And as you can see, if we'd stayed with our original plan, we would have been on the moon by now and building up a lunar outpost. But because of a lot of things, money was a problem, and the amount of money that the the United States spends on space is very much dependent on the president and the Congress giving them the money. And because this was a Bush idea, you know, when Obama came in, he decided to not spend the money on space exploration, but instead on more social programs. And so this lunar outpost was canceled. So the idea is the best place to create a lunar outpost would be at the moon's south pole, because there is a crater here called Shackleton whose rim is actually crosses the south pole. And so this rim, if you get a high enough mast, is in daylight 24/7, we would say on Earth, but in fact on the moon it takes 29.5 days for it to go around once. And so the idea is you can have a solar panel that rotates with the moon and stays constantly in sunlight. Whereas if you had an outpost near the equator, you'd have 14 days of sunlight and 14 days of dark. And so the temperature extreme would be higher, the exposure to cosmic rays would be higher, and you need batteries to store your electrical energy during the long, long night. So we have a vision on how these outposts might look, and they're in several of our planetarium shows. This future moon was we did right after the Bush plan, and so it's, you know, kind of outdated at the moment, but and has been replaced by these other ones. Earth's Wild Ride is our first one where we set the show on a lunar base during a solar eclipse as seen from Earth, which is when the moon gets dark and red from Earthshine. So We Choose Space was an update of Future Moon showing why we went to space and giving some history. Great Planet Adventures is our vision of where we would go if we went to tour each of the planets and what we would do for fun. And Apollo and Beyond is an update of the latest plans for leaving the Earth's surface. So this is the most recent one, and all of our shows you can watch for free on our YouTube channel, ePlanetarium. Go to playlists. There's an English playlist and a Spanish playlist and all of the different languages that we have. So anyway, the Constellation was canceled in 2009, but we are still developing. They still continued development of several things so that when President Trump came in, it was re-expanded again. So there was test flights of Orion. The first one is 2014. It did a perfect ascent abort test where they went, sent off the capsule to make sure it could escape, and literally blew up the rocket, which is amazing. All of the SpaceX rockets are all reusable, which is really exciting. So here's the new plan. It's called Artemis. Artemis was the sister of Apollo. And so the very first Artemis flight will go and do a loop-de-loop around the moon, but not landing. And later ones will actually land. But the first manned one will just do a little much like the early Apollo missions. They just went around the moon and came back. There is a particular orbit you can go to that means that if there's a failure of some kind, you'll still get back to Earth. So this is the upcoming Artemis 1, and then eventually it will lead to a landing. And there's a lot of detail about what the Artemis plan is at NASA. So who will be the first woman on the moon? Well, we don't really know, but we know that women will go. Women are tougher. Women play nice. They're good to have in a confined space for a long time. And you know, maybe one of these women, one of the newer astronauts crew might go, maybe even Shannon or Sunny or one of these that we've just seen. So why do we go to moon instead of Mars for now? Well, it's quicker to get there. It only takes a few days in space, not months. And when you're traveling in deep space, you are exposed to the cosmic rays, both from the sun and from the extragalactic cosmic rays. And that can be really, really dangerous if there's a big solar flare, or if there's a for the Mars mission, that long time in space means the galactic cosmic rays really build up. It's faster to communicate. You can talk to people on the moon in seconds and not have to wait for the speed of light to get to Mars and back. There's a lot of emergency return options from the moon, but much less so for Mars. Mars and the Earth only line up every 2 years, and that's why every 2 years there's a lot of missions that go to Mars, and we're getting ready to launch the 2020 mission to Mars right now, which will be a rover and the biggest rover yet, and one that will actually collect up rocks and make caches of rocks that would could be picked up later. We know that there are resources on the moon. We know that there's water on the moon in these deep craters at the poles, which is the other reason to go to the poles. Is that bottom of Shackleton crater is constantly in darkness, and so it is very, very cold, and so any ice that was brought to the moon by comets is still there and has not evaporated. And that cave, that crater, gives you a natural shelter from solar storms and the galactic cosmic rays. The galactic cosmic rays are so energetic that you need 10 meters worth of regolith, which is a fancy word for lunar soil, to protect you from cosmic rays. Whereas for the solar storms, you only need like 4 inches of water. And again, when you're on the moon, you're in the Earth's magnetic field a part of the year, a part of the month. Well, of course, I'm prejudiced. I did my PhD analyzing data from this instrument that was put on the moon on Apollo 14. So I came to Rice almost 50 years ago as a graduate student, and my advisor's advisor built this instrument called Seepley. His advisor is still alive and lives in Australia. And here I am as a grad student and my advisor, and look at these old computers with big printouts and large data tapes. It was a crazy thing. This was way before personal computers were invented, but we had a lot of fun, and I got a mission badge and got to go to mission control for a lot of events. And I also was able to see Apollo 15, 16, and 17 take off from the moon from in the ALSEP room. So, and my very first scientific publication was looking at the data from the August 1972 solar storm. And that one was so bad that if it had happened during an Apollo mission, it would have killed the astronauts. And we mentioned this in our planetarium shows. I also went back to when we turned off the last experiment on the moon, and we flipped them all off in time, and they flipped off my instrument. I said, oh man, I wish I would have been able to do that. And they said, well, okay, you get to do the next one. So I got to flip the last switch to turn off the last experiment on the moon. And they asked me how I felt. I said, well, you know, it's kind of like pulling the plug on your grandmother. Anyway, so I've been involved with a lot of space missions ever since, mostly unmanned because they stay up longer and keep taking data, and you know, we're studying their extended environment. So atmosphere explore, dynamics explore, polar, and image. This is the launch of the image spacecraft. It was from Vandenberg back in 2000, and this was my one of my mentors who's at Southwest Research in San Antonio, and this was one of my postdocs and friends. This is one of my graduate students. All these people were associated with Rice University that were part of, that came to this image launch. Cluster from ESA, and then most recently is the MMS, which is magnetospheric multi-scale mission, which is a series of 4 spacecraft flying in formation, so they can unfold spatial and temporal changes. So we have planetarium shows on that are related to my favorite way of research, which is called space weather. Those 2 shows are called Force 5 and magnetism. So Force 5 is has 3 sections: hurricanes, tornadoes, and space storms. So the space storms is related to my research in the from image. And then this magnetism show, which is more recently, talks about the science of the MMS mission. So one of the things we like to do with our planetarium shows is to teach the science in a way that's easy to digest and fun to learn. So we've had a lot of women at Rice in space science. We had a separate space science department for 40 years, but then we merged with physics and astronomy department in 2000. So our maximum women faculty were 3 out of 14. We had a high fraction of women graduate students in our department, and we've graduated more like 15 or 20% PhDs in women. So I've had 5 of my students were women, and I'm real proud of the fact that they have gone on and done really exceptionally well. So we have 3 women astronauts from Rice. Here's Shannon when she was a graduate student. This guy, Paul Scowen, did the Hubble Eagle Nebula picture that with those 3 fingers of creation. He was one of the authors of that paper. He and another Rice alum from a previous year. Colin Law is my programmer now for ePlanetarium. So this guy is in astro materials. Several of them work for NASA in various areas of space research. Here's Tammy Jernigan, who was a woman astronaut. This is Eileen Stansberry. Look at that old Macintosh. She is now the head of astromaterials at Johnson Space Center. Here I am, again, old computer, with 2 of my graduate students. Gong Lu is at NCAR in the High Altitude Observatory, studying the ionosphere and the ionosphere magnetosphere relations. And this is Loretta Weiss, who's at Los Alamos National Lab. So two of my grad students that have gone on and done really exciting things. So there's a lot of challenges of working in space because there's low gravity. You will lose bone mass, and that's certainly something that women are concerned about. We worry about solar storms. We certainly worry about galactic cosmic rays. The galactic cosmic rays are there all the time, but at times at solar maximum, the solar wind has a tendency to keep them out, sort of pushes them out. And so it's actually safer to go on a Mars mission at solar maximum than at solar minimum. We can use ice mining for water in these shadowed craters, and maybe bring back helium-3 as a resource. So it may be something that we could actually bring back and use as a way to as a raw material that you can then use for making fusion, making helium out of, instead of doing it from hydrogen, if you do it from helium-3, then it takes a lot less energy, a lot less pressure, a lot less density. And so it makes it easier to do controlled fusion if you use helium-3 as your source material instead of straight from hydrogen. You don't get quite as much energy per interaction, but you get a lot more interactions, a lot easier to contain. And then, of course, you have to worry about going into space. If you plan to have children, you want to be sure you have your children first before you go into space. And that's true of men or women. You can save your eggs, you can save your sperm, but a postmenopausal woman is really best in space because there's no mess and no concerns as much about chromosomal damages. Well, what's up right now is Comet Neowise. So if you haven't been out, for you, it's up all night long. So go out and look for the Big Dipper, and it will be sort of underneath the Big Dipper in the northwest. For you, because you are so high latitude, actually the comet is up all night long. So it goes from the northwest to the northeast. And it'll be up for you from about midnight to 4 a.m. So if you haven't gone out to see it, try to find a good dark sky, preferably up on a hill that you can look north and not have city glows. Now, if you're in a really good place and you have a really good camera, you can see that it has both a dust tail and an ion tail. Okay, so these are dust particles and neutrals, whereas these blue line is ionized oxygen and water, and the red, we're not quite sure. This is a brand new tail. I have never previously seen a red ion tail in a comet, so this is a matter of really a lot of debate right now. Plus, we've had a little space weather. So here's a picture from Canada that of a recent small solar storm we had, that you could see the comet and the aurora in the sky at the same time. And if you haven't seen this guy's website, it really, really is incredible. Here's another beautiful picture of a comet from Mount Shasta. And a lot of people are really looking for cool ways to get the comet framed, you know, with gorgeous things in the foreground. Now, I went out last night, and, you know, Houston has a lot of water in the sky, and it's not very high altitude, and I had this pesky cloud, but fortunately at about 9:40 in the evening, it finally broke through underneath the cloud, and I got to watch it for about 20 minutes between when it set, when it went out from under the cloud and when it set. So if you haven't had a chance to go see the comet, it's take a pair of binoculars, because that really makes a big difference. I have a pair I call my comet catchers, which are like this, and it was gorgeous in that. But you can do it in a regular pair of binoculars. And once you've found it in the binoculars, then often you can see it naked eye. All right, well, that's the end of the show, and I wanted to know if there's any questions, comments.
Thanks, Pat. I think that was fantastic. I mean, it's nice to see a presentation like that, because it reminds us it's been 50 years since, you know, we've been back to the moon. So it's understandable why there's a whole generation that are unaware of all the triumphs that all these men and women have made. Whilst it's very exciting that, you know, there is a lot of energy for us to go back into space and certainly to Mars, and whilst there's economic implications of that, what do you think would be the best way to help certainly the next generation appreciate the value of space exploration, because this generation is very aware of money. And, you know, we don't spend anywhere near as much of the percentage of GDP that we used to. So I know for the US and the UK it's different, but, you know, what would you say that the best way would be to show this next generation why it's so important?
Well, there was a whole generation of people like me who became space scientists because of the space program. I was 7 when Sputnik went up. I was 11 when the first American went into space. So it made a tremendous difference in my personal life. And many scientists are scientists today because of the inspiration they got from seeing the space shots, okay? The space station, some people have kind of gotten a little used to. I mean, it's still showing some amazing photographs, and it's also teaching us a lot about how to deal with bone density problems, which is an aging problem. So it has a lot of relevance to research to help life on Earth. But realistically, it's expensive to go into space, and it's something that you have to say we're going to set aside, and it's less than 1% of the US budget. So, you know, it's still a lot of money, but we still get a lot out of space exploration. We get that feeling of wonder, that we have that understanding of what makes the universe tick. And are we really, really alone? I mean, is it possible that this is the only life there is on this little planet in a backwater galaxy on the corner of the Milky Way? Or is life everywhere? And this is one of those fundamental questions that just drives scientists to want to learn and to want to explore.
No, I agree. And one more question before I let the guys who are joining us ask any questions. You know, our columnists have proved vital over the past few years in engaging schools and children on outreach. I mean, I just think last year here in the UK, we had 150, I think, 1,000 children. And it is also more important than ever to encourage children from ethnic minority backgrounds, and girls certainly, you know, into science, and show them that there is a future in this. It's something that can be monetized, and there's prospects. And I'm guessing we've both had different challenges, you in the US and us in the UK. What advice would you give us to encourage the children here in the UK, certainly girls and those of ethnic minority backgrounds?
Well, when people think of being a space scientist, they think that you have to be a professor or professional in a spacecraft mission or work for SpaceX or something. There are ways that you can be in science and be part of science without getting a PhD, without having to invest years and years of your life in training. You can be a museum expert like you, and you can be a science writer. You can be a technician. You can be an engineer. You can be a designer. You can be a web guru to help spread the word. You can even just be a regular old school teacher. It's a wonderful way to get science into students. And I think with this pandemic, it is so painfully obvious which ones of our communities pay attention to scientists and trust scientists versus the ones who don't trust scientists. And ultimately, I think the survival of human life on this planet is partially, if we don't pay attention to what the scientists say, we're going to be in a big problem, both with global warming and the other environmental issues. Science really helps us know what things can be done and what things should not be done.
No, I agree completely. I think that's fantastic. Well, guys that have joined us, you know, you can either unmute your mics if you want to ask Patricia a question directly, or you can just type. I think I just saw a message pop in.
Oh, yes, I see one. says the milestones in the 1950s, culminating in 1969, were getting first satellite or probes in space to landing on the moon. Is the milestone for 2020 and beyond to build settlements on the moon and Mars? Is that our next stretch and challenge for our generation? Yes, absolutely. So in 1969, our challenge was to get to the moon and get back. That was what Kennedy wanted us to do. Our challenge for the 90s was to build a space station and to establish a permanent outpost in space. And we did that. We've had people now living full-time on the space station for just about 20 years. And now the next step is to, instead of living full-time in something orbiting the Earth, living full-time on another planet. Ultimately, it's not a matter of whether it will happen, but when it will happen. Sometime in the future, and we don't know when, the Earth is going to get hit by a really big asteroid, and it might destroy life on Earth. Having a colony on the moon may preserve human life for future generations. So we need this imperative to get off the planet. The other real important reason for space colonization is that it really shows how difficult it is to make another planet habitable. I mean, we have such a perfect environment for us here. We got water, we got food, we got plants, we got resources. You know, if we were on a gas giant, we'd have nothing, you know, not even a surface to stand on. Yeah. So we really live on a Goldilocks planet, and we've been searching desperately for other Goldilocks planets around in the neighborhood. And we've now found over 4,000 planets around other stars, and only a few have the right Goldilocks temperatures. And even those are not in a very good place. They are too close to the star. It's a red star, so it's not good for photosynthesis. It's a star that might have solar flares that would wipe you out. There are planets that are phase locked, so they always have one face toward their star. So, I mean, we haven't, even with all of our resources, haven't found a good place that we could live on without spending a lot of resources and making it habitable for us. Now, there's a new mission going up soon called the Terrestrial Planet Finder. I guess it's now up, and it is finding, you know, more planets around other stars. But even there, almost none of these are habitable that we could go there right now and live there without major bringing along all of our life support system.
I agree. Right then, guys, if you don't have any more questions, you can obviously type them in the chat window or ask if you want to unmute your mic. We have uploaded some of the videos that we normally screen in the planetariums. You may notice those videos we share with the planetarium. And in Patricia's PowerPoint, you would have seen a link. Patricia, if you want to, you can type a link if you fancy, for anyone to watch your videos on YouTube. Otherwise, I'm going to be off. We will share this with all of our visitors from our other programs today. So anyone who missed this will be able to watch it later on. But any other questions, feel free to direct them towards Pat. Otherwise, thank you, Patricia. It's been fantastic.
Yeah. Well, we do have a question here.
Yep.
So the question is, you mentioned the physical risks, perhaps the DNA, for people potentially living on Mars. Would their bodies be more at risk from radiation, especially as Mars has a weaker magnetic field? Yes, the Earth protects us with our magnetic field, and the magnetic field is so critical for life on Earth for two reasons. One reason is that it allows us to protect, it makes a magnetic shield from both the solar cosmic rays and the galactic cosmic rays. Just can't get to us, and the atmosphere protects us as well. But the other thing that the magnetic field does, and it really wasn't understood till fairly recently, is that magnetic field keeps the solar wind from sweeping away our hydrogen. Hydrogen rises to the top of an atmosphere, and the sunlight then ionizes it. So you end up with an ionized hydrogen, which is a naked proton. That naked proton no longer feels the Earth's gravity. It feels the much stronger electric and magnetic fields in the solar wind, which sweeps it away. And so the reason that Venus and Mars have no liquid water anymore and hardly any in their atmosphere is because they have no magnetic field to keep their atmosphere in, and most importantly, to keep their hydrogen in. And so the oxygen was left behind, and so the oxygen mated with all the carbon, and that's why both Venus and Mars have a carbon dioxide atmosphere, because all the hydrogen was swept away by the solar wind. And I think we'll see that in all of these other, quote, Goldilocks planets that are really, really close to their home stars. If they don't have a magnetic field, they're not going to have hydrogen in their atmosphere. And if they don't have hydrogen in their atmosphere, they're not going to have water. And without water, there's really no life. So yes, both the moon and Mars have essentially no magnetic field. They have small concentrations of local magnetic fields from remnant magnetism from like a volcano that froze out when there was a strong magnetic field. And so it's like a bark magnet that's sitting in the soil, but no dynamo regenerating magnetic field at either Venus or Mars or the moon. And so you don't have that large scale magnetic field to protect you. On the other hand, you do have the body of the planet behind you. So you cut down your radiation exposure by at least a factor of 2, okay? Because they're only coming to you from this side and not from that side. And then at both the moon and Mars, you would probably want, to dig yourself a habitat that was underground in some sense, in a cave or built up, something like that, or in a crater. Again, to give you a little more shelter from those particles, a little higher visibility line, so you have less sky. So the more sky you can see, the more radiation you're going to be exposed to. So when we talk about making permanent installations on both Moon and Mars, we definitely have to take radiation into account.
Oh, fantastic! Well, thanks.
Oh, let me show you. Our website here. So here is our website, eplanetarium.com, and here are a number of our shows, and each of these shows has a website for the show describing it and telling you what it is. So here's our magnetism show, for example. And then you can watch it for free by just hitting View Warped. We have it in Spanish, and we have subtitles in even Norwegian. And then if you watch it, you can either watch it directly from this website, or you can go to our YouTube channel, which is eplanetarium.com. So if you go to youtube.com/eplanetarium, then you go to all the ones that we have posted and go to the playlists. Okay. So now here's all of our Hebrew shows, all of our Spanish shows, all of our English shows, all of our shows in various Indian languages, Korean, whatnot. So all of these are full-length shows with the full audios. Now they're small size and they're watermarked, but so there are quite a few shows that you can watch for free in their entirety. And so be sure you subscribe to our YouTube channel. We also have been doing online planetarium shows every week. And so we can share that with you if you want.
Oh, fantastic. No, we'll definitely share these resources with our customers as well. Thanks.
Okay, well, nice being here with you, and I hope you guys have a great festival and enjoy the rest of your day.
Excellent. Right, thanks, Pat. Thanks, everybody, and see you all soon. Take care. Bye.
Bye-bye.